Objective 3, describe the expected graph for the reaction rate in terms of reactants or products. So similar to the previous objective we looked at, if I have my concentration versus time, if I'm looking in terms of reactants, it's going to be a downward slope, and it's going to be an exponential curve because from the beginning of the reaction, it's going to slow over time. But if this is my curve in terms of H2, you always have to identify which reactant you're looking at, because if I also included the graph for the reaction rate in terms of O2, when I look at my equation, I see I use up 2H2 for every O2. So when I see this curve for O2, the rate will be similar, but the change in concentration is going to be half as much. So in terms of reactants, I'm going to look for a decrease, and I'm going to look for an exponential line. So in terms of products, I'm going to see an increase, and it's still going to be exponential. And there's only one product here, so I don't have to worry about comparing the molar amounts. So now my product, my H2O, is going to look this way. The equilibrium or the plateau should happen at approximately the same place for all three. Either the whole system is at equilibrium or it's not. So my plateaus are approximately the same place. And then the H2O, without actually knowing what my limiting reactant was, the amounts of each, I don't know if my H2O is going to exceed concentration of the H2 or O2 when it reaches equilibrium. That's not something we have to worry about. It's more about the shape of the curve here, that it's exponential, if it's increasing or decreasing, and the comparison of reactants to other reactants or products to other products.